So what we're looking at here is a visualization of the graphs of sine and cosine. In the lower right, we've got the unit circle as it moves through its angles counterclockwise, and that circle in the middle is filling up to show the angle theta that we're looking at. So at 0 or an empty angle, it's all the way on the right, just like the unit circle goes. And then the red and blue lines that come off of that are tracking the x and y positions of that point as it moves along the circumference of the unit circle. Blue being the x value and red being the y value. So as we saw in our study of the unit circle, we know that the x value is going to be the cosine of the angle, while the y value is the sine of the angle. So we're using this tracking to put together the graphs of sine and cosine as they run through their cycle around the unit circle. So we get this wave pattern that shows up for both sine and cosine. And both of these two shapes are the same, actually. There's just a slight difference in where they start, which is why they don't look exactly identical, but it is the same wave shape, just slightly out of phase with one another. On this page, I've stopped the animation and just drawn out the graphs for both sine and cosine on the fixed coordinate axes. So in this case, cosine is red and sine is blue. So be careful because that did change from the last animation we were looking at. But so that red line is going to be our graph of our cosine value. Blue line will be the graph of our sine value. Let's start by just looking at sine. So some points to pick out along the graph of sine. It's helpful to track where the axes fit along this point. So at 0 radians, sine is equal to 0. At pi over 2 radians, sine is equal to 1. At pi radians, sine is 0. At 3 pi over 2 radians, sine is negative 1. And at 2 pi radians, sine is back to 0. And that gets us through just one pass of the unit circle. So notice that this graph goes on forever in both directions. So the graph of sine is infinite, but it does have a pattern that repeats. We look at cosine, which is that red line. We can again look at where those axes fall. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And then cosine of 2 pi is back to 1. And again, this graph of cosine goes on infinitely in both directions. But if we wanted to make our own graph for sine or cosine, we don't necessarily want to have to draw an infinite line in all directions. So since these graphs both have patterns that repeat, we could just graph one cycle of that graph and say that this is what it should look like for the entire length of the graph, just if we repeat this one segment over and over and over again. So that particular cycle that we want to get, we're going to call it the period. So in a cyclical graph or a repeating graph or any sort of a cycle, the period is the amount of time it takes to go through one complete revolution, so to get through one cycle. And in our case, we're going around a circle. In fact, the unit circle. So one period should just be 2 pi. Again, period should have a length of 2 pi, which means I should get the pattern that repeats just by looking within one circle, or 0 to 2 pi, which is this highlighted region shown here. So if I just want to pick out one cycle, I'm going to fill in those dotted lines across those cycles, giving me just this section of the graph. So this is one cycle for sine and cosine. And when we look at transforming the graphs of sine and cosine, we're going to look at just how the first cycle of sine and cosine are transformed. And then say that if we repeated that new cycle in both directions, we could get the entire graph. So all of the detail that we want out of a graph of sine and cosine are just within this one cycle. Let's look at the graphs of sine and cosine, starting with y equals sine of x. So when it comes to the domain of sine, that's asking the question, what angles am I allowed to plug in for sine? What angles x can I plug in? And there are no angles that I would not be allowed to plug in. Whatever angle I'd like to use, wherever it be in the real number line, I can plug it into sine. So there are no restrictions on the domain for this function. So our domain is going to be all real numbers. And later on, when we look at transformations of sine, nothing is going to change that domain. I will always be able to plug in any real number x into sine of x. But we'll find that a bunch of these other values are going to change. Now, the range would be just the y values that I can get for sine of x, and we've seen from the unit circle that we have a maximum and a minimum value for sine. No matter what angle I plug into sine, I'm never going to get a y value that is less than -1, just like I'll never get a y value that's bigger than +1. So my range would be -1 to 1. Now the amplitude in a sine or cosine graph, this represents the distance from the center line to either the maximum or the minimum. Since we're going to see that these graphs are cyclical, so the amplitude is just how far away from the center line we get. In the base case, that center line is the x-axis, and so that distance is just 1, similar to the way that the range is -1 to 1. And since these graphs are cyclical, meaning that there is a cycle that will repeat, we want to know the length of the period, which is how long it takes before that cycle repeats itself. In this case, one cycle is one time around a circle. So that period is going to be 2 pi. Since we're going to be looking at these graphs in radians, and we're only going to be looking at these graphs in radians, degrees ends up being a bit of a headache. So when we're looking at graphs, we're always going to be in radians. Now, in order to come up with the graph of sine, I'm going to want to look at 5 key points. And those key points are going to be the angles that hit the axes on the unit circle. Those points shown here on the right. So I'm going to plot each of those 5 points on my coordinate plane. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. These 5 key points are going to make up the basis for my sine graph. So this bit right here, shown in blue, is one full cycle of sine. Now this pattern repeats infinitely in both directions. So if I extended this further to the right, I would end up with a 0.5 pi over 2, 1, and the 0.3 pi 0, and I could keep that same shape going. Additionally, this could extend beyond the limited graph that I have shown here. And if you'd like to see a more complete graph of that, you can check the Desmos link that's in the class notes. Right, finding the graph of cosine. So just the same way with sine, I could plug any angle into sine that I want. I can plug any angle I want in for cosine. Any real number is a valid angle. So the domain is once again all real numbers. And we have restrictions on the range, just like we did with sine. We've seen the same maximum and minimum values for cosine. I'll never get below -1 or above +1, so my range is -1 to 1. That amplitude is the same. It's just the distance from the center line to the maximum value, in our case, from the x-axis up to 1, so amplitude of 1, and cosine has the same period. Its pattern repeats every full circle, so a period of 2 pi. And I'm going to look at those same angles that hit on the coordinate axes and use that to create the 5 key points that I want to plot cosine. Those values are shown here on the right. So I'm going to take those 5 points and plot them just like I did with sine. So I have the point 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and 2 pi 1. And connect the dots just the same. So these 5 points in red make up one full cycle for cosine. Just like sine, this pattern repeats infinitely in both directions. So I could have the point 5 pi over 2, 0, 3 pi -1. And I could again extend these graphs further in each direction beyond the limited scope of my graph. As we look beyond the base graphs for sine and cosine, and we look to transform those by stretching or shrinking them or shifting them up, down, left, or right, in order to come up with our transformed graph, we are going to look at the changes that are made to these 5 key points, both for sine and for cosine.